I'm very happy that it looks like the industry is aligned regarding the timelines, aligned regarding the frequencies, aligned regarding the challenges. So the question is now, what can I add? I think what I can add from test and measurement perspective, how to overcome those challenges and how to ensure that from test and measurement side, we are ready to help the industry to make 6G come true. So timelines, we heard a lot about that already. So release 19, release 20, World Radio Conference, different frequencies being under discussion, 3GP workshops on first items to be covered in 6G. So our feeling is a little bit when the standardization is ready by 28, then it takes 12 months, maybe a little bit more until the first prototypes, base stations, and mobile phones are ready. So we are looking in the timeline that first 6G networks defined by 3GPP will be ready by maybe end of 29 or in 2030. We had quite a discussion before, are the odd or the even Gs the better ones? At the end, I think it's not important. It's important that we work together to make 6G very successful. The question is now already the right time and the right time to start working on 6G. If you have a look what was happening in 5G with the millimeter wave, then it took, or the first articles were there maybe 2011, then it took 4 years until the first prototypes were available, and another 4 years until the first networks using millimeter wave went live. So altogether about 8 years. If we deduct 8 from 2030, then I'd say it's highest time to get ready if 2030 we want 6G to become true. So from a test and measurement perspective, we always have to think about what is really new, what is revolutionary, what's evolutionary, to be prepared, because test equipment should be ready that you can validate your first prototypes and your first IDs. So we have to be a little bit ahead of the wave. That's a bit our view on the technologies that may be used in 6G. So on top, more the revolutionary ones, new frequencies, potentially terahertz, most probably FR3, integration of communication and sensing. We heard about artificial intelligence, obviously, reflecting interfaces or surfaces, potentially even photonics, and the metaverse extended reality as one of the use cases. And then the usual suspects, like you will have a different waveform, you use either giga-MIMO, massive MIMO, for sure MIMO, and a lot of other topics. So we are heavily engaged in the German community, in Germany by the Ministry of Economy funded research projects on all these different areas to be really ready and understand where the industry is going. And we'll come back to that during my speech a little bit later. Obviously, we are not just focusing on Germany, we are participating in a lot of research together with academia and industry and alliances worldwide to ensure we are ready and can help 6G come true. So we saw this guy already and we had the big discussion, okay, are the odd or the even Gs the better ones? At the end, I think it's about how do we provide for the end customer additional use cases that those end customers are willing to pay for. And we believe XR, augmented reality, making the metaverse really come true might be the big driver for 6G. We had a look this morning already at the different frequency bands, at what World Radio Conference last year was defining on. So upper 6 gigahertz, 7 gigahertz band for sure is of interest. There are discussions in the US, FCC is currently looking at 12 gigahertz, and maybe even above 100 gigahertz will be used. So how do we get ready for that? No, okay. If you look back to 4G, why was 4G a very good commercial success? I think The main reason was there was a new device type, the smartphone, mostly with a touch screen, and with this great ecosystem of applications. So there was a lot of additional benefit for the users. The users were willing to invest into the smartphones and into the apps. That's why 4G was a success. And we now see that extended augmented reality with these additional features of AR, XR classes might be the driver for hopefully killer application for 6G. So immersive, pervasive, interconnected. We heard about the Zoom and the team call. Maybe we'll have holographic calls in the future. Maybe working together will be much easier in the future. And that's where 6G should help us. For us, it's important to be ready. So at MWC this year, we had the first kind of showcase where we were connecting our communication tester, simulating a 5G network in that case, to an application using those classes connected to mobile phone, and to have a kind of avatar call to simulate potential use case of 6G and see how to ensure that is really working. So there are a lot of things you have to take care about. So if you move your head with the glasses, the antenna pattern is changing. Is the connection maybe from your glasses to your mobile phone still working? Is the connection from the phone to the base station working? How do the applications that run on the edge cloud that provide the avatar, how are those working? How do we test that? How do we define new test KPIs to really define the user experience in 6G, that an application like that is running seamlessly? Now if we come to, do we need more spectrum? Do we need more bandwidth? Nokia was doing a research on that and saying for a typical holographic display at a good user experience with the right number of bits per pixel that you have the color resolution and all that, you need somewhere in the ballpark of 450 to 500 megabit per second data rate. Now you could say, okay, this is already weighable in 5G, so 2 gigabit could be possible, but the question is, will that be available on the cell edge? Will that be available for a lot of users at the same time? Most probably with 100 megahertz of bandwidth, that will not be possible to bigger extent, so we need higher bandwidth. And that's where ETRI comes into play, where partly 400, 450 megahertz of bandwidth are available. And that's something where we get prepared for, to already be able to simulate and test things like that today. That's one of the examples. So for higher bandwidth, different frequencies, you have to ensure the components are ready, for example, the power amplifiers. So you need test equipment, in this case, signal generator and a spectrum analyzer that support the frequency, that support the bandwidth. And with our test equipment today already, you can modify the 5G NR to use higher bandwidth and simulate results like that. And you can see error vector magnitude below 1%, which for 64 QRM at that frequency range is quite industry leading. And I can invite you just in front of this presentation hall. We are showcasing all the things I'm showing here on stage, and you can experience it in real life. Our communication testers are prepared for that as well, so supporting already today up to 20 gigahertz, so all the ETRI bands that are currently under discussion we can support today. Yeah, everybody talking about AI. What does AI mean in terms of test and measurement needs, and how we focus there, and how can we help there to make that successful? So if you have a look at the traditional communication diagram from the transmitter to the receiver, which is showcased there, the first idea is replace the traditional receiver by a neural receiver. So how to do that, how to test that. We were teaming up together with NVIDIA, and NVIDIA and their Sionata suite were simulating the neural receiver. But of course, you have to ensure that the performance is really good. You have to understand what's the power consumption. If you put a model like that into silicon, what's the amount of the surface that's needed? Is it really realistic? We were showcasing that at MWC 2 years ago, and we were publishing an IEEE conference paper on that, and there's a 10-minute YouTube video explaining exactly what we were doing there. But it's important to do that in a realistic scenario, and the one we're showcasing was using multi-user MIMO with 2 users that were independently faded to simulate different scenarios, a low mobility and a high mobility scenario, and adding additive white Gaussian noise to make really realistic setup. And the performance was quite good. So the question is, what's the next step then? Receiver, okay, can be a neural receiver. What's going to happen in the transmitter? We heard a lot about custom modulation, maybe non-uniform QAM, and have different types of modulation mapping. So what we are introducing now, that inside our solution today already, beside the QPSK or QAM modulation, you can define your own custom modulation, your own custom mapping. Outside you can see we were using a constellation in the shape of the Rohde and Schwarz logo, just to showcase what is possible to do there. That's something we are doing together with NVIDIA as well. And why could that help? And there's a potential use case where you can get rid of the pilots. If you have your standard data constellation, whatever QPSK or 16QM or whatever, and you superimpose the pilots on that and not use time slots that are originally defined by the standard to be used for the pilots, the red and the gray ones here in the system, you can gain 40% in spectral efficiency just by using custom modulation on the transmitter side. And I think that's very important, and my colleague of Nokia was saying that it's important to find improvements of the current network as well, and not just add too much new complexity. So that's a little bit the timeline, what we were showing regarding AI, regarding how to test AI-driven modulation and demodulation. So first, Mobile World Congress 23, showing the neural receiver. Then in Brooklyn Summit by end of the year, adding a really end-to-end learning network that helps to train the neural receiver. And MWC this year, the neural receiver and transmitter, and adding impairments, because we saw when we were working together with NVIDIA, you really have to train the neural receiver with realistic signals. If the signal is too good, then the receiver is not learning properly. So you have to add AWGN and fading and things like that to make a very realistic scenario and to ensure that the neural receiver is really having great performance. So I was speeding up a bit because it's time for coffee. And we heard a lot of the things I was talking about before already, so I didn't want to bore you with the timelines. I think the important thing is 5G deployment is still in full swing. We are still working on improving 5G, but researchers, academia, and the industry are exploring new technical components to be more efficient, more intelligent, more sustainable, more secure. We are ready today to help the industry to make 6G come true. And we think that extended augmented reality will be a big driver, a big use case for 6G in the future. And we are actively engaged there, and let's work together to make 6G come true and become real. Thank you very much.
Thank you for your insightful